So let's look at this example. We have a figure later that shows the travel time between two towns. Then the question is, where would you locate a depot to give the best customer service? The best customer service here measured by the delivery time, so it's equal to the shortest delivery time. And the second question is, how many depots would be needed to give a maximum 20 of 15 minutes? So let's look at the figure. We have how many? We have 10 facilities. So the green color is the travel time between two facilities. For example, the travel time between A to B is 10 minutes. So the same as the single median problem, but here it's not distant. But here we measure it by the delivery time, the travel time. But the same that we have to find the smallest time to travel from one facility to another facility. For example, from A to C, we have obviously two ways to go to C. That from A to B, then B to C, and from A to D and B to C. So we have the pink way and the yellow way. If we follow the pink line, the total time to travel from A to C is 10 plus 14 is equal to 24. If we follow the yellow line, the total time to travel from A to C is 10 plus 15 is equal to 25, right? So we will take the minimum travel time, that is 24. So the same, we can calculate the time from travel time from A to G, A to E, A to F, so on and so forth. And we can make this matrix. So this matrix is similar to the distance matrix we made in the single median problem earlier. So we have from A to A is 0. From A to B, the minimum time to travel from A to B is 10 minutes, and the minimum time to travel from A to C is 24 minutes. And so on and so forth. You can fill this matrix. And then in each location, we will see how long is the longest time for the customer to wait. So if we locate the facilities in A, we can see that the maximum time the customer has to wait is 35 minutes. And if we locate our facility in B, the longest time the customer have to wait is 30 minutes. So on and so forth, you can determine what is the longest time the customer have to wait if you locate your facility in C, D to J. And then we will compare the maximum time the customer have to wait between different locations. So here we can see if we locate our facilities in C, the longest time that the customers have to wait is the smallest, that is 25 minutes. So we will choose C to be our single location so that we can cover all the customer in the smallest time. And we have the single location is C and the maximum time is 25 minutes. The second question is how many, if we locate at C, the maximum time is 20 minutes, but the customer wants the waiting time, the maximum waiting time is 15 minutes in place of 25 minutes. So to achieve the customer requirement that the maximum 20 is 15 minutes, how many deports would be needed in this case? So we will just take the time that are less than 15 minutes. So for A, we will take this from if we locate in A, we can serve the customer in B because it's in 10 minutes. 24 no, because we want if we locate our facility in A, we cannot serve the customer in C within 15 minutes. But for D, we can. For E, F, G, H, I, J, we cannot because it's over 15 minutes. So we have 2 points. If we locate our facility in A, we can satisfy the customer in A, in B, and in B. If we locate our facility in B, we can satisfy the customer in A, in B, in C, in E, in F. Sorry, not in E and F because it's already over 15. So in G. So if we compare, if we locate our facility in 2 deports, that is A and B, we can satisfy the customer in A, B, C, D, and G, but we cannot satisfy the customer in E, F, H, I, and J. So that if we locate our facilities in 2 deports, that is A and B, we cannot satisfy the customer, we cannot serve the customer within 15 minutes. So it's not satisfied our requirement. However, if we put another facility in C, we can satisfy the customer in B, in C, in D, in E, in F, in G, and in I, and J. So we compare again. If B and C, we can satisfy customer from B, A, B, C, D, E, F, G, I, and J, but we cannot serve the customer in H within 15 minutes, so it's also not good. How about D? We can satisfy the customer in A, in C, in D, in H, so if we see from C to D, we can satisfy the customer in A, B, C, D, E, F, G, H, I, J. So if we put our location in C and D, we can satisfy the customer within 15 minutes, right? So on and so forth. We also do the same thing for the rest of location. So we will have several options to put our location. For example, A and I are also okay, or C and D is also okay. So in the exam, I just require you to have you choose one pair only. But if you can see several pair, you can list all out and tell me which one you prefer and the reason why. For example, here we have A and I also certify the requirement, and C and D also certify the requirement. So we can compare for C. If we locate the first facility in C, the maximum time the customer have to wait is 15, right? Because 14, 0, 15, 11, 5, 15, 11, 14. So the maximum is 15. For D is also 15. So compare A and Y and C and D, which one is better? Of course, if we locate it in A and I, is better because the longest the longest time customer has to wait is only 10 and 15. But here, the longest time customer has to wait is 15 and 15. So here is better service. So you can choose. We should locate two new depots, so that can serve all the customer in within 15 minutes, and two locations are I and A.